Hello and welcome to part 7 on our video series building a TypeScript and Postgres API. So far within our video series we focused on building out our TypeScript API and starting our Express server and all those different parts. And now we want to start moving towards integrating Postgres with our API. Now, Postgres, for those of you who haven't worked with it before, is a database, and it allows us to store relational data that we want to use for our project. Within our project, we're actually going to use it to store a couple of things. We're going to make an API that stores books and authors. So there are relations between the two, and in this video, what we're going to do is talk through how we actually set up Postgres locally, and to do that, we're actually going to make use of a tool called Docker, which is a really useful tool for every engineer to get some familiarity with, as it provides a lot of functionality locally on your machine. If you do want to follow along with me, there is a link in the video description to the GitHub repo that we're using. And if you check out part 7, the branch part 7, then you'll be exactly as we are here within our code base so that you can follow along with us. Now, first things first, what I would suggest doing is installing Docker on your local machine. Now, the installation guide for Docker will vary from machine to machine. So the best thing that I can advise people to do is head over to docs.docker.com/desktop, and that will give you instructions based on your operating system on how to install Docker Desktop, which will come with a whole bunch of tools that we're going to make use of in this video, most notably Docker Compose, which is what we're going to use to stand up a local Postgres database. Now, the reason that we're going to use Docker is it provides you with a really easy way of standing up external servers such as Postgres in a very throwaway manner. So we could, in theory, install Postgres on our local machine, start up a Postgres server every time we log onto our local machine. But what you'll find is working as an engineer, you'll actually want to access lots of different bits of software, different servers, and Docker allows you to stand up just what you need in a self-contained environment, and then when you're finished with it, chuck it away without needing to completely reinstall your local environment. So follow along with the instructions and get your Docker set up, and once you're in a position where you are able to run Docker commands and you have the Docker CLI installed, then what we're going to want to do is start to provide some instructions to Docker for what we want it to do. Now, for our particular project, we're actually going to make use of a file called a Docker Compose file, and this is essentially going to contain instructions for Docker on what to stand up when we ask it to. So let's just write some YAML here, which will essentially describe what we want. So we're going to put version 3.9, then we're going to describe the services that we want Docker to stand up. And the one that we actually want to focus on today is Postgres. And in order to stand up a service using Docker, you need to provide it with an image. And what we're going to use is Postgres 15-Alpine. The Alpine image is essentially a really stripped down Linux distribution so that it doesn't install oodles of dependencies on your machine and take up loads of space. So we've got the image Postgres 15 ports. So this is going to describe what ports should be used by Docker and what ports should be mapped to your local machine. Postgres runs on port 5432 by default. So we're going to make use of that port to map to our local database instance. Next, we're going to set up some volumes. Volumes will allow us to persist data between between our local machine and our Docker machine, so that when we shut down our Docker machine at the end of the day, we don't end up losing all of the data because there's a local copy of it stored on our machine with a mapped volume. So we're going to just do /db API. We want it to map to lib PostgreSQL data, which is essentially where the data is going to live on the Postgres server. Next up, we're going to want to provide some environment variables as well. Environment, and we're going to want to provide a few variables that our Docker instance will make use of when it's standing up. So the first one is going to be Postgres password, and we're just going to put that as Postgres. And then we're going to have Postgres user, and we're just going to call that one Postgres. And then we're going to have Postgres DB equals Postgres. Now, this is okay for a database that's running on your local machine. Obviously, you wouldn't use the same username and password. You probably wouldn't even use the same user as we're using here, or the same database name. Just from a security standpoint, you'd want something a little bit more random, or certainly a much better password than the one that we have here. But because this is just a database that's going to be running on your local machine, there's nothing wrong with having it nice and simple to begin with. Now, what we are going to do now that we've got our Docker Compose file, if we're in the root of our project here, which we are, when we run Docker Compose up-d, which essentially is going to start a Postgres database and run it in a daemon, so in the background for us. And what you'll find is if you already have a Postgres image on your machine, which I do from all the work that I do on a daily basis, it'll just pull it together very easily and start everything up. If you're installing it for the first time, you're probably going to have a couple of minutes while it pulls down the Postgres image and then starts everything. And this is all we're looking for. A couple of entries here just to say that it's created and started. And if you ever want to just query what's running at the moment, you can just do docker ps, and it'll show you that on our local machine we've got a database stood up. It's listing on port 5432 and forwarding that onto 5432 within the Docker container. And how long it's been up for, when it was created, etc., etc. So now that that's running, what we can actually do is we can connect up to our database using a tool. I generally recommend a tool called dbeaver. dbeaver is a free tool, has a community edition, and it allows you to connect up to a myriad of databases, as you can see here. The one that we're actually looking for though is Postgres. So when you start up dbeaver, it may come up with this screen to connect to database, or you may just need to click on this little plug icon here just to create a database. We're going to go ahead and choose Postgres. This is all going to be normal. It's going to be based on localhost 5432, database Postgres. Localhost database Postgres, username Postgres, and then we've got the password of Postgres as well. Then you just want to hit test connection, and what you should have is that you're able to connect up to your database without any issues. Once you click finish, it'll come up under this connection here for you. And when we start to add data into our database, you'll notice that this area over on the right here will fill up. So you'll start to have databases, you'll start to have tables within your database, and then you'll be able to see the individual data, bits of data within your database as well. So we'll wrap the video up here because we don't want it to go on for too long. We've set up our Docker instance. We've now got a database stood up that our project can make use of, and in a way that isn't going to pollute your machine. So for example, when you're finished for the day, you can simply run docker compose down, and that will actually stop all of your Docker instances, so it's no longer running. So that's how easy it is to create a throwaway database on your local machine with Postgres. I hope the video has been useful. In the next video, we'll have a look at how we define some of the data that's going to go into our database. So we'll actually start defining a database schema, taking a look at things like indexes, IDs, and what a data model can look like for the data that we're going to be working with. So I hope this has been useful, and I'll see you in the next one.